Let's take a look at what the graphs of absolute value functions look like.
It's a nice V, okay? Some people confuse it with a parabola, but remember a parabola is curvy, whereas this guy comes to a point as that sharp corner. You have points 0, 0, 1, 1. So you have a slope of 1 to the right. You have the slope of -1 to the left. And when we say parent function, that just means the basic graph before any transformations. You're not adding, subtracting, or multiplying to shift or reflect the graph. We're wanting to graph a couple of transformations based on that original parent function. So let's focus on this one to the left. We know it's an absolute value, but what does this new function tell us? The negative on the outside of the absolute value, we had it just like this. That means we're multiplying a negative by all of the f of x values or all of the y values. So that means we are first going to reflect about the x-axis. The second thing is when we're adding that 3 inside to the x. Remember, those inside changes works opposite the way we think. So when we add a 3, we're actually going to shift left 3 units. And the last thing is we're subtracting 2 from the entire function. So that means we are going to shift down 2. Okay, so a couple of things. When you're doing some of these transformations, it might help to do them one at a time or group them, but you need to know what the parent function looks like. So if we were to regraph the parent function, I'm going to do it here just in a dotted blue. And multiplying all of those output values, in other words, all of the y's by a negative means it's going to flip over the x-axis. So flipping everything downwards, our graph is going to look like that in purple. And now we can shift all of those points left 3 and down 2. So I'm going to do that final graph in black. So I'm going to start at my origin here, and I'm going to shift it to the left 3 and down 2 right there. And my next point on the left, I'm going to shift it left 3 and down 2 here. And if you remember, we haven't really stretched or compressed anything, so all of those slopes are going to be the same. So we can just keep going here, down 1 over 1. And we can do our final graph in solid. So that's been reflected about the x, shifted left 3 and down 2. Now in this graph, they're asking us to do something slightly different. This time they've given us the picture of the graph and they want us to determine what the original equation is. Well, we can tell by the shape of the graph that we are dealing with absolute values because the shape is a V. So if we were to graph lightly here what a parent function of an absolute value looks like, okay, again, parent function would be f of x equals the absolute value of x. Then we need to see how this graph has been manipulated or transformed to give us the other graph in blue. Well, first of all, it does not look like it's been reflected, right? It's not going over the x-axis or opening downwards. And even if we reflected it across the y, we would get the same graph back because it's even. So there's no negatives being multiplied. But then we also look at whether or not this guy has been stretched or compressed. Well, looking at the original V, it definitely looks wider than the second V to the right. So notice in this first equation here, in the first original parent function, it goes over 1 and up 1. But in this new function, it goes over 1 and up 2. If there was no stretch or compress, it should have landed here over 1, up 1. So instead of going to 1, it's going up 2. That means we've stretched the y values, because it's going upwards, we've stretched the y values by a factor of 2. So in our new function, we have a 2 being multiplied by the entire function, original function. I'm not finishing that absolute value because we might be doing more manipulation. And then we need to figure out if this guy has been shifted left, right, up, or down. So on this, I would again focus on points that we know. For example, the tip of that V and the tip of this V. How did we get from the origin over to 3, -2? Looks like we have shifted to the right 3 units and down 2 units. Using our knowledge of transformations, we shift right 3. That means we're actually subtracting 3 from the inside x value. When we move down 2, that means we are subtracting 2 from the entire function. Now, there are 2 ways that we can actually check this. We can use a table, and we can plug in values for x. For example, if I plugged in 2 for x, I get 0 for y. That's a true point right there. If I plugged in 3 for x, I would end up with a -2 for y. That is correct. So you can test it to make sure, or you can also graph it on your graphing calculator.